Recently, the FCC has recommended that all carriers provide at least minimal DNSSEC functionality. Additionally, they've proposed incremental rollout of full DNSSEC functionality, mostly to mitigate the risk and complexity to the carriers themselves. There are only a handful of carriers that have fully deployed DNSSEC, and the reason for this is the staff requirements. Carriers who have been early adopters to DNSSEC have dedicated significant staff resources to deploying the technology and configuring it. In addition, they have ongoing requirements to their staff to monitor the DNSSEC deployment and adapt to failures that occur within and outside of their control. DNSSEC is great in that it enhances the security of the internet, but proper DNSSEC deployment depends on two things. First, it depends on the proper configuration of software and hardware inside the provider. However, it also depends on the successful configuration of keys, cryptographic signatures, all on remote authoritative DNS servers outside the control of the carrier. If there is a failure in DNSSEC processing, that appears to the customer as being unable to access a remote website. The customer has no idea if the website is down, if the carrier's internet connectivity is down, or whether it's a DNSSEC failure. In fact, customers are really unaware of DNSSEC at all. So because of that, the carrier is at risk for massive help desk calls or being blamed for outages that are completely out of its control. Initially, carriers should provide DNSSEC processing only to business and consumers that request DNSSEC processing. By using a programmable policy engine, a carrier can split their DNS traffic and segregate DNSSEC from non-DNSSEC. In this way, you avoid any cross-pollination. Failures on the DNSSEC side do not affect customers who don't request DNSSEC processing. By using Xerocole technology, you get separate caches, separate responses, and separate processing for all DNSSEC. The second thing we recommend is to start out with soft failures. And what that means is when there's a DNSSEC failure, rather than reporting it directly to the customer, proceed as if no failure had occurred. Log the failure, collect statistics on the type of failure, where the failure occurred, as in what domain, and what customers would have been affected. By collecting that data, which all of our products do, a carrier can make the appropriate timeline for making a transition into hard failures. Finally, when a carrier makes a transition from soft failures to hard failures, they can use our programmable policy engine to decide what customers are exposed to those hard failures, what domains are exposed to those hard failures, and how those hard failures are exposed. For example, one of the things we recommend is using a policy that provides a delay between the failure of DNSSEC and exposing that failure to the customers. This gives remote websites time to fix any intermittent DNSSEC failures that may occur due to key rollover or other types of failures. All of our policies are enabled by simple tables and programming within your DNSSEC infrastructure so that you don't have to dedicate staff resources to validating DNSSEC failures or inserting cryptographic things like negative trust anchors into your DNSSEC infrastructure. At Xerocole, we believe it's much more than just turning on and off DNSSEC functionality. Check out the Xerocole website at www.xerocole.com. We have white papers and instructions that talk in more detail about how carriers can deploy DNSSEC functionality in their networks today.